How does a neural network actually learn? Today is day 24 of learning computational astrophysics, and I moved into deep learning. Before moving into neural networks, I started with loss functions. A loss function gives us a number describing how good a model's prediction is compared to the actual value. So training a model really just means we're trying to make that loss smaller. Gradient descent helps us do this. We calculate how the loss changes when we move each model parameter, and then move those model parameters slightly in the direction that reduces the loss. The size of each step is controlled by the learning rate, and a neural network builds on this idea. Each neuron receives some inputs, multiplies them by a weight, adds a bias, and then passes those results through to an activation function. And then those outputs become the inputs for the next layer. So during a forward pass, information moves through the input features, through the hidden layers, until the network makes a prediction. We then compare that prediction with the true value and calculate the loss. But now we need to know which weights were actually responsible for that error, and this is what backpropagation does. Starting from the output, we work backwards through the network and use the chain rule to calculate how sensitive the loss is to each weight. Gradient descent then uses those gradients to update the weights. So basically, the full training setup is make a prediction, calculate the loss, backpropagate those gradients, update those new weights, and then repeat. I also looked at activation functions like sigmoid and ReLU. These introduce nonlinearity, allowing networks to learn much more complicated relationships. Finally, I looked at techniques like regularization, batch normalization, and dropout. These help make the training more stable and reduce overfitting. But that was day 24. See you next time!